Hello everyone, this is Pampi Morandante again, and today I will talk about circle theorems. Okay, here we go. Here are some words you will often encounter when working with circles. The first number one we have here, this is the radius. Number two, illustration, look at that, that is the circumference. Number three, check this out, that's the center. And number four, we have here, check, that's the arc. Okay, next one. Okay, here we go for the next illustration. For number five, this is the diameter. Look at the one in red, that's the chord. This is the tangent, okay? And this is the sector. And last but not the least, this is what we call the segment, okay? So remember them, we will be making use of them. Okay, this is the chord. Remember that the chord is a line segment joining 2 points in the circumference of a circle. So look at them. Okay, well, the tangent here is a straight line that touches a circle only once. Okay, so that's the meaning of the tangent, only once. It touches the circle only once. Okay, check this out. A line segment drawn from the center of a circle to the point of a chord will intersect the chord at right angles. Look at the illustration below. So the chord AB is intersected by a line segment OM, wherein M is the midpoint. So AM and MB are the same length. Okay. Here we go for the next one. A tangent and radius meet at right angles. Look at the illustration below. This is the radius and the tangent. They meet at right angles. Okay, take note of that. Here's another theorem, guys. Look at this. The two external tangents to a circle are equal in length. So look at the illustration below. These are equal in length. Okay, next one. Okay, so here's a situation now where we can apply what we have learned a while ago. The diagram shows a circle O. PT is a tangent to the circle. Find the value of x. Okay, so if that's the case, remember that PT is the tangent here and OP is the radius, meaning they meet at right angles. So this is a triangle. So the sum of all the angles is equal to 180. And then since the radius meets at right angles with the tangent PT, therefore you have there 90 degrees. So 90 plus 48 is 138. Subtract it from 180, the value of x there is equal to, what do you think, guys? Is equal to 42 degrees. So that is the value of x. Next one. So here's another problem. The diagram shows a circle center Q. AB shows a chord across the circle. M is the midpoint of AB. Find the value of y. So if that's the case, here, this is the right angle. Okay, so just simply subtract by the sum of 90 and 62. There you go. What do you think is the value of y, guys? So that's 28. So y there is 28 degrees. So here's another problem here. The diagram shows a radius OT that bisects the chord AB at M. MB is equal to 12. The radius of the circle is 13 centimeters. Work out the length MT. So just check the illustration. We are going to supply the information. OB is radius, that's why it's 13. And OT is also a radius. Take note of that. So for OM, just simply apply Pythagorean theorem. That's why you have there MT is equal to 8. Okay? Because you just subtract 13 by 5, which is the measurement of OM. That's why MT is equal to 8. Okay? Up next, angular properties inside a circle. This angle at the center here, O, is twice as big as this one at the circumference. This one, the angle X. So take note of that. Okay? That's how are they related to each other. In order to understand, let's give an example. Let's say this X here is equal to 45 degrees. Then 2X here is equal to 90. Otherwise, if this is equal to 50, then the other value is equal to 100. So if we are going to give the value of O, which is equal to 120, what do you think is the value of X? That's equal to 60 degrees. So don't forget this theorem. The angle subtended by an arc at the center of a circle is twice the angle subtended by the same arc at the circumference of the circle. Here's another theorem. The angle subtended in a semicircle is a right angle. Check this out. If this line is a diameter, then this angle here, look at this. This must be equal to a right angle. Okay? So that's the meaning of that. We are down now to our last theorem. Look at this. These are three angles which are all equal, PQR, with the same arc. meaning the angles subtended by an arc in the same segment of the circle are equal. Okay? I have here a problem. Solve for x. Look at the given illustration. So what do you think is the value of x here? If the other angle there is 28 degrees, so this must be equal to 56 degrees. Just simply multiplied by 2, right? Okay, remember the theorem. Next one, look at this, subtended by the same arc. So this angle x here must be equal to 31 degrees. Okay, so here's the last problem. Find the missing angle by applying circle theorems. Number 4. So check this out. So if this is O is 78, then H must be just simply divided by 2. Then that's 39 degrees. For number 5, look at this. That must be also equal. They are subtended in the same arc. So therefore, angle I must be equal to 44 degrees. Number 6. The given is 32 degrees and the diameter O, which is subtended by this angle, this must be a 90 degree angle. Okay, so to find out J, just simply 180 minus 32 plus 90. So J is equal to 58 degrees.